Good morning. Let us study today transformation matrices. What are called transformation matrices or matrix representation? For example, you have studied 5 different symmetry operations: identity element, center of symmetry, plane of symmetry, rotational axis of symmetry, etc. So each symmetry operation is represented in the form of matrix. This matrix is called transformation matrix. What is transformation matrix? It is used to carry out symmetry operations. The symmetry operations on a molecule is carried out by using transformation matrix. Okay. For example, identity element is a symmetry operation is represented by this matrix. Center of inversion, center of symmetry or inversion center is represented by this matrix. Now let us see how it works. For example, let us take an atom position in a molecule X, Y, Z in Cartesian coordinates. Okay, so the position vector R bar is expressed in terms of X, Y, Z, where I cap, J cap, K cap are unit vectors along X axis, Y axis and Z axis. The matrix form of identity element is equal to this, is represented 1 0 0 0 1 0, and for example X axis along X axis X only will have value, therefore 1 0 0, this is X, Y, Z, and Y axis, this is the vector, this is the X vector, Y vector, Z vector. Okay, now along for Y vector only there will be Y value, there will be 0 value for X, Z, similarly Z. Okay, now let us do symmetry operation, transformation symmetry operation on the, let us do identity element operation on the position of atom X, Y, Z. Okay, when you do this, see, by using matrix multiplication you will get X, Y, Z. E is doing nothing. What is identity element? It is doing nothing. It does nothing to molecule. Therefore, the position vector remains unchanged. The molecule is unchanged. Okay. Now, what is called the character of the matrix? This is a matrix. What is called character or trace of the matrix? It is equal to sum of the diagonal elements. It is equal to sum of the diagonal elements. It is represented by chi. For example, chi, the character of identity element operation is equal to 3 because the diagonal elements 1 plus 1 plus 1, 3. Okay. Now, let us see inversion center. The inversion center symmetry operation is represented by this matrix minus 1 0 0. Okay. So let us do center of inversion on the position of the atom. For example, X, Y, Z on center of symmetry minus X here. Okay. Therefore minus X minus Y minus Z. When you do symmetry operation on X, Y, Z, you will get, okay, by matrix multiplication minus X minus Y minus Z. So we have obtained this. So this is the matrix form of inversion center. Let us see the matrix of rotational symmetry. For rotational symmetry, when the rotation is along about Z axis, when the rotation is carried out about Z axis, Z axis, Z won't change. Therefore 0 0 1. You see 0 0 1. This does not change. And similarly this also Z does not change. Only X, Y changes. When the rotation about a molecule is carried out along about Z axis there won't be any change. Therefore 0 0 1. So cos theta, it is represented by cos theta minus sin theta cos theta. For example, the position vector is rotated by theta. Position vector is rotated by theta. Therefore, the term becomes cos theta. This becomes minus sin theta. This becomes sin theta. This becomes cos theta. The other terms are same as identity element. For example, C2Z. C2Z means C2 operation. That is rotation by 180 degree. That is how Cn equal to 360 by n. C2 equal to 360 by 2. Therefore, it corresponds to 180 degree rotation of the molecule about Z axis. 180 degree means it will come here. Okay, the position. Therefore, but the Z won't change. Z axis won't change. Therefore, minus here it was minus x minus y. Therefore, minus 1. If you put cos pi, sin pi rotation, theta equal to 180 degree rotation, then cos pi equal to minus 1, sin pi equal to 0, therefore sin pi equal to 0, cos pi equal to minus 1. Now, the character of the C2 matrix equal to minus 1, the sum of the diagonal elements. Okay, minus 1. Let us do transformation matrix. This is called a transformation matrix. Let us do symmetry operation. X, Y, Z. On symmetry transformation on symmetry operation, it will become minus x minus y and z. Since the rotation is above the z axis, it is and the z is unchanged. The z position is unchanged. Only minus x minus y are changed to minus. Okay. Similarly, C2x, if the rotation is above the z axis, x axis, then the atom in the x axis the position does not change. Therefore, minus y minus z. The next one is plane of symmetry. The plane of symmetry is represented in the following matrix form. For example, sigma xz. The sigma xz means the plane is in the sigma xz. Therefore, x and z does not change. Therefore, this is 1 0 0 0 0 1. Only y changes because the plane of symmetry, the mirror plane is in the xz plane. Therefore, xz does not change. Only x, for example, this is xz and this is y. This comes here and therefore this is minus. Okay, y. Xy, this is xy, the matrix form of xy, and in the case of xy plane, the xy does not change, only my x minus 1. Plus 1 becomes minus 1. Okay. The character of the plane of symmetry, mirror plane equal to 1. The sum of the diagonal elements equal to 1. Let us see now improper axis of symmetry. It is represented by S and Z. It is a compound symmetry operation. It is a combination of axis of rotation and plane of symmetry, mirror plane. For example, S2Z is the combination of twofold rotational axis along Z axis and mirror plane perpendicular to the, followed by plane of symmetry perpendicular to the Z axis, that is sigma xy. So C2Z, you know that C2Z, the matrix form of C2Z is here, and the matrix form of sigma xy is here. So on multiplication, by following the matrix multiplication, the S2Z, the matrix representation of S2Z symmetry operation is obtained, is shown here. Now, this complete set of matrices, transformation matrices, this set of transformation matrices of a group is called matrix representation. What is matrix representation? These matrices of symmetry operations present in a molecule, is called matrix representation, and these matrices also follow group postulates. They form a group, therefore they also follow a group postulate. Okay, thank you for watching.